All right, so calculus students, this is a video to kind of look at problems 30, 31, and 32. And, you know, what's frustrating about these problems, sometimes people don't know what to choose for u. And, if I chose, say, u is equal to secant, then du would be secant of x tangent of x. And you don't see a secant tangent, so that's not a good choice. Um, Most of the time, if you're going to choose u to be something, you choose u to be something that if you were going to take the derivative, you would use the chain rule. And you can look at that substitution. So sometimes people say, well, should u be sine? And then the derivative is cosine, or is u cosine, the derivative is sine? Well, in this case, u is equal to cosine of t. And du is then equal to negative sine of t dt. And we have to have it like that because you have the sine of t dt. Notice that this part is on the inside of the secant. So it's literally sine of t times secant of cosine of t quantity squared. And so as you have this dt here, the dt is really connecting with the sine of t. And so that's why we want to make that substitution. And so we therefore know that negative du is equal to sine of t dt. So now by doing negative integral du, so once I get something like that shows up over here, I then like to make my substitution. And I cross stuff off. So I cross that off and I cross that off. And a lot of people get really frustrated with this because they're like, well, where does the secant go? Where does the cosine go? Just trust it and watch as you write it and see if there's something you can work out. We know that u is cosine, so we have secant squared of u. So I didn't get rid of the secant, but I did get rid of the cosine. Now, this just really makes you have to know what the antiderivative of secant squared is. Or in other words, what do you take the derivative of to get secant squared? And you take the derivative of tangent. So we substitute u back in, we get cosine. Negative tangent of cosine of t plus c. And that's that antiderivative. So that's a tough problem. None of these are easy. 30, 31, 32, these are all fairly tough. So I wouldn't feel bad if you're having any trouble with them. If you look at problem 31, there u is equal to x plus 2. And again, it's on the inside of this function. And so again, if you were going to take the derivative, you would use the chain rule here, and this would be the inside. That's a very good indication that you made the right choice. However, in this situation, as you write du is equal to just dx, 1 dx. So that's all we have. We just have a straight up substitution. Du just gets rid of dx. That's all I have. What about x? Well, we don't come up with an x over here, but over here we can come up with an x. You see, u minus 2 is equal to x. And so that's what makes this problem really tricky, is seeing that we can generate that x over here. And so we have a u minus 2 over, and then this is u to the 1/4 power. And now that looks very similar to a problem we had in our notes. It'll be the integral. This is u to the 1 or u to the 4/4 over u to the 1/4. That'll create u to the 3/4. And then minus 2u to the negative 1/4 du. The antiderivative of u to the 3/4 is u to the 7/4 divided by 7/4 or multiplied by 4/7. And then if you add 1 here, you get u to the 3/4, and you divide it by 3/4 or multiply by 4/3. And so as we substitute the x plus 2 back in, 4 times x plus 2 to the 7/4 over 7 minus 8 times x plus 2 to the 3/4 over 3 plus a constant. So that's tricky right there. That's not an easy problem at all. Not an easy problem at all. For 32, I'll go ahead and write it down on a scratch sheet of paper. We have the integral of x squared over the root of 1 minus x. So I'm going to write that there just because I might need a little bit extra space. Looks like I'm running out of room there. And hopefully you see that the substitution is 1 minus x. So if the substitution is 1 minus x, that means du is equal to negative dx. I don't have a negative dx. But if I multiply by negative 1, negative du is equal to dx. So integral negative du, I get rid of that dx. But I got a lot of stuff to account for yet. Like this x squared, for example, I don't have that anywhere. But I could come up with an x. If I add the x and subtract the u, I get x is equal to 1 minus u. In order to get x squared, I can take x times x. And if you multiply these together, you get x squared. You're going to get u squared minus 2u plus 1. And so that's what you have on top, u squared minus 2u plus 1 over, and then as you look at this bottom here, that's going to be u to the 1/2. Now my substitution is complete. I only have u variables left. I got rid of this x squared with this top piece here, and I got rid of the square root of 1 minus x by using u to the 1/2. So everything is accounted for. So I have negative integral, and u squared is u to the 4/2. Divided by u to the 1/2 is u to the 3/2. Is 2u to the 1/2. And then we have u to the negative 1/2 there. Du. So negative, the antiderivative will be u to the 5/2 divided by 5/2 or multiplied by 2/5. It'll be a plus 2u to the 3/2 divided by 3/2 or multiplied by 2/3. And then the antiderivative u to the negative 1/2 will be, notice the negative comes from out front here, by the way, be u to the 1/2 divided by 1/2 or multiplied by 2. So there you have it. Now it's just a matter of substituting it back in. And you have 1 minus x raised to the 5/2 power over 5 plus 4, 1 minus x to the 3/2 power over 3 minus 2 times 1 minus x to the 1/2 power plus a constant. And that's my antiderivative. So there we have it. There's those 3 problems. I want to be clear, though, that these are definitely challenging problems here. The majority of your concern, even problems like 25 and 27, 26, those are definitely seen as more challenging. People do struggle with those. But hopefully you're feeling good about problems like, say, 17 and problems like, say, 23, problem like 22. 22 may look really difficult, but after you give it a little bit of time, hopefully it seems pretty straightforward. Problems here, hopefully a problem like number 9 seems very simple to you. Hopefully problems like 13 and 15 seem very straightforward. Problem 16 hopefully seems very straightforward. These are a little bit more the basic ones. We definitely get to a little bit more challenging ones. And we really just want to stretch your brain. And sometimes they're tough to see right away. And when you ask yourself, how do I know what to choose u to be? There's not always a real clear answer. The best thing to do is when you choose u, find out what du is and try to set up the integral. And if it works out to be something you can take the antiderivative of, good. But if not, then choose a different u And sometimes there's multiple u's that you can choose. So hope that helps a little bit. Three tough problems. Ask again if you need help. Look forward to visiting with you guys soon.